Stoichiometry refers to the relationship between the relative quantities of substances taking part in a chemical reaction. This means the relative quantities of the reactants and the products formed during a chemical reaction. Now, in this part of stoichiometry, I have prepared an example here, so I hope via this example you are going to get the full concept on stoichiometry, the full concept on how various problems concerned with the stoichiometry are solved. This problem states that potassium chlorate decomposes to yield potassium chloride and the oxygen gas through the application of heat under the presence of manganese 4 oxide. Part A. Write a well-balanced chemical equation for this reaction. Part B. Calculate the volume of oxygen gas at STP, meaning standard temperature and pressure, that is liberated when 20 grams of potassium chlorate decomposes. Part C. You have to calculate mass of potassium chloride produced associated with the production of 0.25 mole of oxygen gas. And the last part, you are required to calculate the number of moles of potassium chlorate from which 30.85 grams of potassium chloride will be produced. Now, let's see the solution. Part A, you are required to write a well-balanced chemical equation for this reaction. You have to note that for any problem concerned with the stoichiometry, you have to be competent with the idea of balancing chemical equation, because failure of balancing the chemical equation will lead you to have wrong answer. Now, you have to be careful, making sure that you've balanced well the equation corresponding to that particular chemical reaction. Now, let us balance our equation. Our equation is the decomposition of potassium chlorate. As you know, potassium chlorate decomposes on the presence of manganese 4 oxide by applying heat to give potassium chloride and oxygen gas. This is the equation. We are given that is potassium chlorate, written this way. Potassium chlorate, this is solid. It decomposes under the presence of manganese 4 oxide, written this way, MnO2, manganese 4 oxide, and the application of heat to yield potassium chloride and oxygen gas. This is a gas. Now the next step is to balance our chemical equation. We have one potassium, one chlorine atom, 3 oxygen atoms, 2 oxygen atoms. So for the part of oxygen atoms are not balanced. Now let's balance. To balance these, we multiply this by 3. Now we have 6 atoms of oxygen, and this is multiplied by 2, so as to have also 6 atoms of oxygen in this part. After multiplying this by 2, it has made potassium to be 2 atoms, chlorine 2 atoms, so even this part is multiplied by 2. To have 2 potassium, 2 chlorine atoms, 6, 2 times 3, 6 oxygen atoms, and here 6 oxygen atoms. So it is now balanced. I remind you that the section of balanced chemical equation is very, very important, because when you balance it in a wrong way, it will lead all equations to be wrong. So you have to be careful when you balance your chemical equation. Let's go to part B, whereby we are required to calculate the volume of oxygen liberated at STP when 20 grams of potassium chlorate is decomposed. From this balanced equation, the relation now to be considered is the relationship between oxygen gas and potassium chlorate. You are given potassium chlorate and you are required to calculate the volume of oxygen gas which is going to be obtained from this when this 20 gram of potassium chlorate is decomposed. So now you have to relate potassium chlorate and oxygen gas. How do they relate in the balanced chemical equation? We find that 2 moles of potassium chlorate is equivalent to 3 moles of oxygen gas. So let's see the solution for this. We may say that from a balanced chemical equation, in A above, we find that 2 more of potassium chlorate are equivalent to 3 moles of oxygen gas. From this, that's equivalent to 2 moles of potassium chlorate equivalent to 3 moles of oxygen gas. But we are given, for the part of potassium chlorate, we are given 20 grams. 20 grams. Now, for us to bring this 20 gram here, it should be changed into moles. So let's convert 20 gram of potassium chlorate into number of moles. Let's see molar mass, that molecular mass of potassium chlorate. In potassium chlorate, we have 1 potassium, 1 chlorine atom, plus 3 oxygen atoms. This will be equal to the relative molecular mass of potassium is 39, chlorine is 35.5, and for oxygen, we take 16 times 3 as we have 3 atoms of oxygen, plus 3 times 16. The answer obtained here, let's compute. We have 39 plus 35.5 plus 16 times 3. We get 122.5 gram per mole. 122.5 gram per mole. This is the relative molecular mass of potassium chlorate. So you have to know that number of moles is equal to mass divided by molar mass. Now this will be equal to, we are given mass 20 gram. Molar mass obtained 122.5 gram per mole. Whereby when we compute, we get 20 divided by 122.5. The answer is 0.16327 mole. Now, we have already converted the mass of potassium chlorate given, which was 20 gram, into number of moles. Now this one is suitable to be here. Let's now turn back to our relation. Our relation is that here, 2 moles of potassium chlorate is equivalent to 3 moles of oxygen gas. Now, what about 0.16327 mole of potassium chlorate? For the part of potassium chlorate, we are given from the 20 gram given, the number of moles is equal to 0.16327 mole of potassium chlorate is equal to how much in terms of moles of oxygen gas? So to get this value, we may cross multiplication this way. Now, to get the number of moles of oxygen gas present in 0.16327, when you cross multiplication, it will be equal to 0.16327 times 3 divided by 2. When you cross multiplication, we are going to get the number of moles of oxygen gas in 20 gram will be equal to, we take this times this one divided by 2. So it will be equal to 0.16327. We multiply it by 3, then we divide by these 2. And the answer obtained here is going to be this times 0.16327 times 3. We divide by 2. We get 0.24245 mole. These are the number of moles of oxygen gas that will be liberated when 20 grams of potassium chlorate decomposes. After getting this number of moles, but you have to remember that question requires us to find the volume of oxygen gas produced. So we have to convert this number of mole into volume of oxygen gas at STP. We know that at STP, 1 mole of a gas is equal to 22.4 decimeter cubic. 1 mole of a gas is equal to 22.4 decimeter cubic. Now we are having 0.245 mole. Now 0.245 mole is equal to how many decimeter cubic? So again, in cross multiplication. So to get the value here, which is not known, we take this 0.245 times 22.4 divided by 1. Now the volume of oxygen gas will be equal to 0.245 times 22.4, but the answer should be in decimeter cubic. We get 5.488, which is approximately to 5.5 decimeter cubic. Now the volume of oxygen is 5.5 decimeter cubic. This will be the answer. This is the answer. 5.5 decimeter cubic will be the volume of oxygen gas liberated when 20 grams of potassium chlorate is decomposed. After that, let's go to the solution of part C. In part C, you're required to calculate the mass of potassium chloride produced associated with the production of 0.25 mole of oxygen gas. As usual, our mirror is the balanced chemical equation, this one. Now, from the balanced chemical equation, we find that here we are going to rate potassium chloride and oxygen gas. Potassium chloride and oxygen gas. These two, the product, or other product, potassium chloride and oxygen gas. We find that 2 mole of potassium chloride is equivalent to 3 moles of oxygen gas. 3 moles of oxygen gas. Now, how many moles of potassium chloride will be there when 0.25 mole of oxygen gas is produced. Now, for the part of oxygen gas, we are given 0.25 mole of oxygen gas. Now, this will be equivalent to how many? This will be equivalent to how many moles of potassium chloride? Now, I have assumed this as Xc. So to get this value, which I have assumed to be Xc, to get this, you have to take this times this one divided by this. 0.25 times 2 divided by 3. Now, our value will be equal to 0.25 times 2 divided by 3. But the answer is more, in more. Now, let's compute this. We have 0.25 times 2 divided by 3. You get the answer is equal to 0.167. These are more. So when 0.25 mole of oxygen gas is produced, at the same time 0.167 mole of potassium chloride will be produced. Therefore, 0.167 mole of potassium chloride will be produced. After that, let's finish with the last part, which is part D. In part D, we are required to calculate the number of moles of potassium chlorate from which 30.85 grams of potassium chloride will be produced. So according to this question, it is simply that the relation is between potassium chlorate and the potassium chloride. Now from this balanced chemical equation, we find that 2 mole of potassium chlorate is equivalent to 2 moles of potassium chloride. 2 moles of potassium chloride. Now, here we are given 30.85 grams of 30.85 grams of potassium chloride. So potassium chloride is given in terms of mass. So as here the relation is in moles, we have to convert the 30.85 grams of potassium chloride into number of moles. So let's start with the molar mass of potassium chloride. Potassium chloride. The molar mass of potassium chloride, we have 1 potassium here plus 1 chlorine. So it will be equal to, this one is 39. We add with the 35.5, which is the molar mass of chlorine. Now when we add the 2, 39 plus 35.5, we get 74.5. 74.5 grams per mole. This is the molar mass of potassium chloride. What about number of moles? We know number of moles is equal to mass divided by molar mass. So this one is going to be equal to, mass given is 30.85 grams. The molar mass obtained is 74.5 grams per mole. So the number of moles here, the number of moles will be equal to 30.85 divided by 74.5. We get 0.4. We get 0.414 more. But the relation is this one. 2 moles of potassium chlorate is equivalent to 2 moles of potassium chloride. Now, they are equal. So, as we have obtained 0.4141 mole when we relate it, when we put into this relation, we may find that the number of moles of potassium chloride is equal to the number of moles of potassium chloride. So even the number of moles of potassium chloride required will be 0.4141. Now, 0.4141 mole of potassium chlorate will be used. Now, the number of moles of potassium chlorate will be 0.4141. The number of moles, 0.4141 mole of potassium chlorate will be used. This is the end. Now we have finished to calculate all 4 parts of this problem. We are through, and I hope you've understood well on how stoichiometry is applied in calculating various relative quantities between the reactants and the products. Thank you. Keep visiting our channel, Theophil Academy, so as to get many updates when we upload various videos on different class sessions. Thank you. Have a nice moment. Bye.